Hello, and thank you for taking the time out of your day to engage in some professional development with me. Before we begin, just a bit of housekeeping. All references used in this presentation are included within the slide deck or at the end of the presentation. Today, I wanted to take the time to discuss the importance of explicitly teaching reading and writing in our technologies learning area and how we can implement effective reading and writing sequences that meaningfully support literacy and numeracy skills. I'm sure that we can all agree that literacy and numeracy play a significant role in how our students navigate and participate in the community, making integration across areas essential. As Jewett explains, literacy is no longer confined to printed text. Instead, it traverses the boundaries between home and school through social media and global literacy culture, something we as digital technology teachers see every day. Our students regularly engage with digital interfaces that blend symbols, images, numbers, and sound, meaning that their literacy and numeracy is increasingly multimodal. Students are consequently required to interpret, critically evaluate, and make meaning through multiple forms of representation. As educators, it is our responsibility to support our students in navigating these new literacies, explicitly scaffolding reading and writing sequences to ensure that they develop as confident, capable, literate, and numerate learners. Today I'll be drawing on my Year 7 Digital Technologies class to demonstrate how these sequences can be embedded in practice. Digital Technologies has specific literacy and numeracy demands, which require intentional scaffolding to support engagement and understanding. Our class is currently learning how digital systems represent integers and binary, and how these integers are used to represent images and audio. To support this learning, I've selected a BBC Bitesize online guide as our multimodal text. Table 1 in the slides highlights just some of the literacy and numeracy skills that our students must be able to navigate in order to interpret this resource. For students, reading is a complex series of events that involves cognitive, physical, social, and emotional dimensions. Everybody in Loop's full resource model helps us to understand this complexity. So in our context, in our Year 7 students, they must break the code by decoding technical symbols and discipline-specific vocabulary and conventions. They must make meaning across modes, connecting embedded video, written explanations, and diagrams. They act as functional text users, reading with purpose and intent, and they also act as text analysts, critically evaluating language choices and website design features. Given these demands, it becomes clear why students require explicit scaffolding before they are able to synthesize, extend, and transform their reading and writing. To support this process, I use the three-phase approach to reading, which consists of pre-reading, while reading, and post-reading activities. The pre-reading phase prepares students to learn and engage meaningfully with the text before it was read in full. Its primary purpose is to activate prior knowledge, build meaningful context, and to make the purpose of reading explicit. When students understand the social purpose, audience, and structure of the text, comprehension is significantly improved. In this sequence, pre-reading activities include unpacking how the website functions, explicitly teaching navigation strategies, and breaking down technical vocabulary. Teaching students how to navigate, use headings, hyperlinks, and embedded media supports their understanding of salience and positioning, extending contextual knowledge. Modeling reading strategies such as skimming, scanning, and keyword searching also helps students to select appropriate reading strategies for different purposes. A key strategy and activity I use in this phase is the KWL chart that supports the explicit teaching and development of discipline-specific literacy vocabulary. At the Year 7 level, students are expected to be able to decode the unfamiliar digital technology vocabulary to be able to comprehend the text. So according to the Queensland Curriculum and Assessment Authority, and further supported by Kane, the KWL chart scaffolds reading by prompting students to identify what they already know, what they want to know, and what they have learned. KWL, know, want to know, learned. In the pre-reading phase, we focus on the K and W. L is completed during the post-reading phase. The K section and teach literacy skills, I explicitly model how to identify existing knowledge related to the topic. So keep in mind this is after you've already introduced the topic and clarified the purpose of reading. So the first thing I do is students are asked to examine the title and record any associated ideas or provide them prompt further. So when you look at the title, Fundamentals of Data Representation, what comes to mind? What words does it make you think of? Write this in the K column. So at this stage, make sure to give them time to respond 5 minutes or so before asking the class as a whole what they came up with. So using their input, I would then prompt them to think about the topic more and the associated language. So what do you know about the pictures and how they appear on the computer screen? So after this conversation, I then explicitly introduce the key vocabulary. So binary, bitmap, pixels, resolutions, and metadata, asking them where they might have encountered the terms before and what they might mean based on the sound and familiarity. So, have you ever heard these words before? If so, where? Do any of them feel familiar, even if you don't know what they completely mean? What other words do you know that might be similar? Can anyone explain the terms in your own words? What might you think it might mean based on how it sounds? Write down in your case section what you think you know about the words. So these questions build on prior knowledge while building a sequence preparing them to read the text with comprehension. To solidify the student's literacy understanding of the key terms, after completing the first section, I would then in the W section prompt students to identify which one of these terms they need in order to comprehend the text. So which one of these words do you think we must understand to make sense of the text? Looking at the headings and images, which terms might be important? Students might then suggest pixels. Why do you think the word pixels will help us understand the text? Why might resolution matter when talking about image quality? And if we don't understand this word, will the text still make sense? How will we know when we've learnt what the word means? At this stage, I would then point out that on the website, the vocabulary that I have just pointed out have a little eye next to them. So when you click on them, it will display what the word means in context. This activity helps to guide students to recognize the importance of vocabulary in meaning making, ensuring that they are prepared, literate, and able to read the text with confidence. The while reading phase focuses on supporting comprehension as meaning is constructed. Here, students engage with the text through teacher modelling, think aloud strategies, annotation, and explicit connections across modes. These activities might include interpreting diagrams, questioning the credibility and purpose of the website, evaluating how meaning is constructed through language and visual design. Jerry Wiancott notes that the comprehension is strengthened when students are guided to recognize how meaning is made through language choice, structures, and visuals. One effective strategy I use is a jigsaw activity, where students make meaning and then justify their understanding. Credibility checklists can also be incorporated into this phase, reinforcing critical evaluation and online safety. It's as an ever-present and essential component of learning. This is something that will inevitably occur. After students complete the reading, the post-reading phase focuses on consolidation, reflection, and comprehension extension. In this stage, students are supported to synthesize, evaluate, and respond to the text, transforming reading into knowledge. Students complete the L section of the KWL chart, reflecting on how their understanding has changed. Learning can then be extended through creative consolidation tasks like creating pixel art using binary, allowing students to apply knowledge learnt in a fun and meaningful way. Throughout the reading sequence, there are a myriad of formative assessment opportunities to help you guide in your lesson planning. These include KWL charts, jigsaw collaboration nodes, the credibility checklists, and creative pixel art artifacts. Collectively, they provide valuable insight, helping you to catch any misunderstandings and further inform your lesson planning and differentiation. Expanding on the reading sequence, the writing sequence is introduced progressively across several lessons. The writing sequence is not a short process as it takes time for students to plan, draft, revise, edit, and then share their work. As supported by Jarawinka, the teaching and learning cycle helps to explicitly scaffold this process for students by building field knowledge, analysing model text, constructing joint meaning before students are then able to construct meaning independently. In this unit, the students will write a short explanatory report with a label diagram explaining A, B, and C as written on the slides. Each section of the report will include definitions of important words, the processes addressed, a sequence explanation of the correct tense, and explanation of components using action verbs. Special features will be included at the end. Now that we know what the students will be writing, let's consider the actual writing sequence as implemented within the reading sequence. To scaffold the writing process, the first phase of the teaching and learning cycle is building the field, which occurs in the pre-reading stage. This phase focuses on engaging students, activating prior knowledge, and exploring how the text is linked to cultural and society, beginning to develop shared understanding. Pre-reading activities like the KWL chart supports this process. However, incorporating a think, pair, share activity while completing the chart strengthens alignment with the written task. It is this activity that the students will then discuss existing knowledge with their partner, collaborating and organising ideas before sharing with the class and completing the KW section of the chart. At this stage, it is important to the students that they are introduced to topic-specific language that they can then start to hear, see, and use key terminology in the correct context. The next stage of the cycle is modelling the text, which occurs in the while reading stage. This stage is introduced once students are about halfway through their reading after the jigsaw activity. By this stage, they should have a foundational knowledge of the text and are starting to think about how it will inform their writing. During modelling, students examine the explanatory report they will be writing, looking at how the text genre is organised to achieve its purpose, how language choice shapes meaning, and how meta-language is used. One effective strategy is to present a model explanatory paragraph directly from the reading and analyse it in a think aloud process. This strategy allows me to explicitly model the report and teach numeracy skills by deconstructing the paragraph and demonstrating how algebraic equations are interpreted and used in context. The model text that I use is displayed on the slides and is visually color-coded to support students' text organisation. I would begin by giving them the text and then deconstructing what each section relates to in terms of the report and why it is included in the example. So when we are writing our report, we start with a definition, followed by an explanation, and then finalise with an example. So the paragraph is deconstructed into definition, explanation, and example. So from here, I would explicitly link the example to the equation and text, explaining how I translated the formula into words. So I didn't just make up this explanation, I took the words, language, and equation from the text. So as you can see, the formula is actually W multiplied by H multiplied by CD equals file size, or width multiplied by height multiplied by color depth equals the bitmap image file size. Does this make sense for everyone? I would then consider the language features, annotating the paragraph to identify key language features. So looking at the paragraph, you can see that I've used technical nouns like width, height, color depth, bits, and bytes. Consider the mathematical language used as well, calculated by, multiplied by, and is equal to. Lastly, reports use a precise and objective tone. So this means that in our report, we avoid personal opinions and use third-person writing to reflect conventions. It is made explicit that the paragraph was constructed and drawn from the source text. Through this strategy, numeracy skill demands are intentionally integrated, demonstrating that a successful report should look like and supporting students to comprehend the remainder of the text. This prepares them for the next phase, where they begin to construct their own explanations. During the post-reading stage, students revise and refine drafts, focusing on coherence and language features. At this point, students are ready to move on to the next stage of the cycle, which is joint or guided instruction. At this phase, an effective strategy is to develop a paragraph collectively around topic sentences, which contribute from the whole class. The teacher then prompts deeper thinking, responding to suggestions with how, why, which one. Or I could even present a poorly written paragraph and ask for improvement or recasting. This allows students to rehearse language, refine sentence structure, and develop cohesion. Through guided construction, students gain a sense of how drafting the report should look. This process also allows myself as a teacher to give immediate feedback on sentence structure, vocabulary, cohesion, punctuation, and spelling, supporting students in independent writing. The final stage in the writing process is independent construction, completed before the KWL activity in the post-reading phase. At this phase, students will be taking full responsibility for composing their report. They draw from their knowledge of the field, text, purpose, key language, and functionality to draft, edit, and revise. As supported by Flint, a key strategy in this phase is having a clear success criteria to guide student work and self-reflection. I've included the student success criteria on the slides for you. To conclude the writing sequence, students then share their reports with a younger year level, making the task more authentic and purposeful. Knowing what the work will be read by others, and encourage students to write using clearer, more precise language, considering the audience, their understanding, while building confidence and responsibility. The process is completed before returning to the KWL chart to reflect on that new learning. Throughout the writing sequence, multiple opportunities for formative assessment are embedded. Evidence is gathered during the think, pair, share, observation of student engagement during modelling and joint construction, as well as through the evaluation report itself. I also find that using exit tickets or Kahoot quizzes throughout the phases can further check comprehension. Collectively, these provide a clear picture of student understanding and areas that might require further scaffolding. Effective reading and writing sequences are essential in digital technologies, as the subject requires students to interpret complex multimodal text, translate technical and mathematical concepts into precise written text. When reading and writing are deliberately integrated and scaffolded, students become confident meaning makers who can interpret, evaluate, and communicate complex digital concepts effectively.